Okay, multi-step synthesis. I highly recommend you check out the reaction summary document under the organic tab on our OneNote. Okay, for multi-step synthesis, you're always going to be asked to write a series of reactions to prepare a particular molecule from available organic reactants and any inorganic reagent that you require. So I've got a reminder here of the inorganic reagents, perhaps HCl, Cl2, H2, water, or ammonia. As I mentioned in class, you definitely want to work backwards. So whatever that target molecule is, we're going to figure out the reactants to make that target molecule and then work our way backwards to the available organic reactant. So the first example here, we're being asked to prepare propan-2-il ethanoate from 2 alkenes. Any inorganic reagent we require is available to us. So in starting with the end in mind, I would draw propan-2-il ethanoate and sequence that structure in a reaction at the bottom of your workspace. So I'll draw the ethanoate, so I'm thinking of 2 carbons and the ester functional group, and then propan-2-il, so a 3-carbon R group attached to the oxygen off of the 2nd carbon. I know in an esterification reaction that water is released, and I need to figure out the 2 reactants that form this ester. So if you've reviewed your esterification reaction, then you'll remember that it's a carboxylic acid and an alcohol that form the ester. Now, are these 2 organic reagents, this ethanoic acid and the propan-2-ol, are those allowed starting materials? And if I look back up to the question, no, they're not. So I'm going to need to work those both back to alkenes. So I'll pick one of them, for example, the carboxylic acid, and I'll start preparing that. So it's a 2-carbon carboxylic acid. So now I need to go into my series of reactions and remember how to prepare carboxylic acids. I recall that aldehydes are oxidized to carboxylic acids. Now that aldehyde's not an alkene, so I need to back up and prepare that aldehyde. And I remember that water's a second product there when a primary alcohol is oxidized. Now that primary alcohol of ethanol can be prepared by the hydration of ethene. And so all of these reactions here, starting with the ethene to ethanol, ethanol to ethanal, ethanal to ethanoic acid, they all prepare this carboxylic acid required for the esterification reaction. So now I need to prepare this alcohol, and I notice that it is a 3-carbon alcohol with the OH attached off the 2nd carbon, a secondary alcohol. So I need to place my double bond in such a way that I can hydrate the double bond, adding and follow Markovnikov's rule. And by following Markovnikov's rule, the H will go to the 1st carbon here with 2 hydrogens on it, and the OH will go to the 2nd carbon that has only 1 hydrogen on it in the alkene. And that's it, because now I've worked my way back to a 2nd alkene. So it said that I had to prepare the target here, which is this molecule here, from 2 alkenes, so 1 and 2, from any inorganic reagents. And so I needed water twice and oxidizing agents, which I don't need to specify. So there'll be 1 mark for drawing the structure correctly, and then 1 mark for each reaction in order. And so this question would comprise 6 marks. This is the 1st reaction, 2nd, 3rd, 4th, and 5th. Okay, let's move on to the 2nd example. So here's question 2. Prepare N N-dimethylhexanamide from an alkane, an alcohol, and any inorganic reagents. So if you understand the strategy, then you can try this question ahead of me. But start by drawing that amide and sequence it at the bottom of your workspace and figure out the reactants that make it, and so you can write the complete reaction. So start with that and then check in with the video. Okay, so here is the N N-dimethyl 1,2,3,4,5,6 hexanamide. Water is released in this condensation reaction between the carboxylic acid and this secondary amine. And so the organic reagents that I'm allowed to work with or start with are an alkane and an alcohol. So I recognize that this carboxylic acid came from an aldehyde, and so I can show the preparation of that carboxylic acid like so. And I realize that aldehyde isn't an alkane or alcohol, so I need to prepare that aldehyde. Having memorized that reaction, you will recall that it's a primary alcohol that oxidizes to an aldehyde. So it's quite possible that that could be the alcohol here. I think I'd better look at the other side and see if I can work my other reagent here. So I'm now looking to get this amine. I possibly could work that from an alkane. So paying attention to your amine lesson and the reactions that were there, this is a secondary amine. And so a hydrogen has been replaced off of that nitrogen. So you'll see the difference here is that one of the hydrogens, perhaps this one, has been replaced with a CH3. So how did that happen? Well, we added an R group with a halogen attached, so a haloalkane, and that allowed us to substitute, producing the byproduct of HCl. And so now the primary amine here is not an alkane. Again, I'm working backwards. And so I need to prepare that primary amine. So there's a CH3 group there. And again, I'm thinking substitution. So I'm going to put a hydrogen back in place of that CH3 and then add that haloalkane. Again, substitution producing HCl. Now, have I got back to the original alkane? Well, this is ammonia. That's an inorganic reagent. This is a haloalkane. So in fact, I still need to prepare this. And so I'll go back and prepare the haloalkane by substitution, halogenation in particular, of methane. And that produces a byproduct of HCl. And so now I am back at CH4, which is an alkane. And so this alkane is methane, and this alcohol is the hexane 1-ol. Inorganic reagents, it required Cl2, ammonia, and oxidizing agents. And so we have 1, 2, 3, 4, 5, 6 reactions, including drawing the target molecule correctly. This question would be out of 7. You do lose half marks for missing byproducts, so it's important that you know the details of your reactions. You'll find practice on the OneNote, and we'll work on that in class tomorrow.